This code implements the Monte Carlo simulation algorithm to calculate the price of European call and output option. Black-Scholes formula is used to price option based on several parameters such as stock price, strike price, time to expiration, risk-free investment rate, and volatility. This code has the two implementation of the Monte Carlo simulation algorithm, one on CPU, another on GPU. The CPU implementation uses the Numba library, which compiles Python code into optimized machine code. The GPU implementation uses the CUDA programming model, which allows the code to run on NVIDIA GPUs. The CPU Black-Scholes function implements the Monte Carlo simulation algorithm on CPU. It initiates the input parameters, generates random numbers, calculates stock prices and option payoffs, and return the call and put option prices. The GPU Black-Scholes function uses a vectorized decorator from Numba library to compile the Python code into GPU kernel. It performs the same calculation as CPU Black-Scholes function, but so on the GPU using the CUDA programming model. The Monte Carlo simulation function uses the kernel decorator from DPCT library to compile the Python code into GPU kernel. This function implements the Monte Carlo simulation algorithm on the GPU using the CUDA programming model. It generated random numbers, calculates stock price, option payoffs, and option prices. Finally, the code run Monte Carlo simulation function runs the Monte Carlo simulation algorithm on both CPU and GPU and return the call and put option prices and the result of linear regression. The DAL4 PY library is used to perform linear regression. Now we can review the code. The code starts by importing various libraries including NumPy for scientific computing, Numba for JIT just-in-time compilation and GPU acceleration, SYCL buffer for data transfer, DPCT for heterogeneous programming, DPCTL for DPC++ compatibility layer, DAL4PY for machine learning algorithm, and TimeIt for time execution. This code defines vectorization function CPU Black-Scholes using Numba. It calculates the black hole formula for a single set of input values S, K, T using GPU. This function is decorated with @vectorized get square bracket within quotes float64 within bracket float64 comma float64 comma float64 close bracket comma square bracket comma target value cuba bracket, which means it is compiled to run on the GPU and can accept 3 float64 input arguments. This code defines a function normCDF using Numba. It calculates the cumulative distribution function of the standard normal distribution for a single input value x. This code defines a function using Numba. CPU Black-Scholes. It calculates the Black-Scholes formula for a large number of simulations using the CPU. Initialize necessary input parameters such as stock price, strike price, time to expiration, interest rate, utility. This is a kernel function for running Monte Carlo simulation on a GPU. It takes in several parameters including the number of simulations to run, the number of time steps in the simulation, the initial stock price, the risk-free investment rate, the volatility, and arrays for storing the call and put option payoffs. Inside the kernel, it first calculates the matrix of normally distributed random numbers using the NumPy normal function. This is used to stimulate a random moments in the stock price each step in the simulation and calculate the stock price at each step. It does in the parallel for all simulation using the responsible for. After calculating the stock prices, it uses the NumPy maximum function to calculate the call and put function payoff for each simulation. Again, this is done parallelly in all simulations. which each thread responsible for calculating the payoff for a single simulation. Finally, it calculates the option prices by taking the mean of the call and put option payoff and discounting them to the present value using the risk-free investment rate. It uses the call and put prices. Run Monte Carlo simulation, then calls this kernel function and return call and put prices as well as the result of the linear regression. The linear regression is done using the DAL4py library to fit linear models to call and put option prices as a function of underlying stock price. Result of regression is then returned. I thank you for your time, and I'm sorry if you can't able to understand few of the words as I'm having mouth ulcer. I will also attach. Thank you for understanding. Thank you.